Good morning, Tehmina Khan is here in TKMaths S1. In today's video, we will see the concept of work, power, energy with the help of the question taken from March 2 variant 4 to question 1. This topic is a part of the syllabus of A-level Mathematics M1. And for the rest of the videos on this topic or any topic of A-level Mathematics, you can refer my blog address and my website address, which is here. The link is given in the description as well. So before seeing the question, we need to recall few concepts which will be applied in this question. So number one is about work done. So work done is equals to force into distance. And when we write distance d cos theta, it's because whatever the angle force is applying at, we take its horizontal component, which will be like this, which is ft cos theta. So work done is equals to force into distance. Second concept you have to revise or recall is about energy. Now we have studied two types of energy, kinetic energy and potential energy. They represents what is the work done due to different reason. Kinetic energy is due to motion and potential energy is due to change in position. So the kinetic energy formula is half mv square. Mass should be in kg, velocity should be in meter per second, and potential energy is equals to mgh. M is in kg, h is in meter, and g is the gravity, force of gravity, right? And then another concept you need to recall is power. Now, power is a measure of the rate at which work is done. Mostly you remember the formula of power is equals to force into velocity. So depend what we need to apply there basically. This is at times a student forget, which is power is equals to rate at which work is done. So P is equals to W upon T. So work done is equals to power into time. So you need to remember these. According to the requirement, you can apply them. Again, work done is in joules, power is in watts or kilowatts, and time is in seconds. So let's see the question now. A crane is used to raise a block of mass 600 kg at a constant speed through a height of 15 meter. So distance it covers when it is taking the block up is 15 meter. And you have to find the total work done by the crane. Now there is another important thing given in the question, and that is this. There is a resistance to the motion of the block, and to overcome that resistance, the crane has to does 10,000 joules of work. So we will see it now. So to find the total work done by the crane, first of all, you need to remember here one thing. And it is the potential energy of a body, right? Is the energy that is possessed by virtue of its position. So what does it mean? So when we say potential energy is equals to mgh, which is written here, right? So that is the work done when the crane is lifting the block up. So to calculate the work done, we simply do here work done is equals to mgh. We are substituting the value of mass, which is 600 kg. G is 10, that is the standard we take in mechanics. And H is 15 meter. So when you multiply, you get answer here 90,000. Now mostly students stop here, the common error. They forget to add 10,000 here. Now 10,000 is the work done by the crane to overcome the resistance it was facing. So you will add this 10,000 in it. So the total work done by the crane is 100,000 joules, right? I hope you understood this question. Let's see second part of the question. Given that the average power exerted by the crane is 12.5 kilovolt, which is equals to 12,500 volts, you have to find the total time for which the block is in motion. Now there are two ways to do it. So the one which is easy here is that power is equals to force work done divided by time, right? Power is equals to work done divided by time. So power we have already calculated, or it is given to us in the question, which is 1200. And work done we have calculated in part 1, which is 100,000. So you simply substitute the values here and calculate the time, which is 8 seconds, right? So power was given in the question, work done you have calculated in part 1. So you just substitute it here and get the time. There is another way to calculate the time by using another concept. I would say the other way to do it, which is also, little lengthy, but it's same thing. So we know that power is equals to force into velocity, and work done is equals to force into distance. So power is given to you in the question 12,500. Force you can calculate from here. Force is equals to work done divided by time. And you already know that velocity is equals to displacement divided by time. So this is how we are replacing velocity by displacement into time, and force is equals to work done divided by time. And after that you just substitute the values here. Work done is 100,000, displacement is 15 meter, and time you have to calculate. So these are the two ways you can calculate your time taken by the crane to move the block 15 meter, and it was exerting a power of 12,500 watts. So I hope you understood this question. Please share it with your friends if you think it is a useful information and good to revise the concepts. So take care. Allah Hafiz.